So electricity numericals children. Electricity numericals. This is video 4 from past 3 classes. I'm telling numericals only. So one more. Okay. First question. A wire is there. It carries a current of 0.1 amperes through a resistance of 120 milliohm, 120 milliohm per meter. Okay. What is the potential difference? What is the potential difference across 1 meter of this wire? What is the potential difference across 1 meter of this wire? Okay, children, 1 meter. So 120 milliohms per meter he said, across 1 meter means per meter only he said, no problem. So normal formula only children, V is equal to IR 0.1 into 120. How to millimeters what children? By 1000. Okay,
1000.
okay children. So if you remove this point also, one more zero will come down. If you remove into 120, so 0 0. So potential is equal to children. So what will be the potential? Potential is equal to 12 by 1000. That is potential is equal to 0.012 volt. 0.012 volts will come children. Okay. Next one. Second. Okay, children. One more question. Second question. So second question is there like this: an electric iron draws a current of 4 amperes. An electric current draws a current of 4 amperes from 220 volt. From 220 volt supply. Okay. When voltage of supply is changed, then iron draws a current of 2 ampere. Then 2 ampere. Okay. What is the new voltage applied? What is the new voltage applied? Okay, children, they are asking. Initially, it is drawing this much. When the voltage is changed, it is drawing 2 amperes. How much is that? In this case, first you find resistance. R is equal to V by I. R is equal to 220 by 4 ohms is the resistance of the wire. Resistance of the wire does not change, no children. That you substitute here. So V is equal to IR. V is equal to I is 2 amperes. R is 220 by 4. Okay, so 110 volts. When potential is half, current also halves. According to which law? When potential is half, current also halves. According to which law, children? Anyone?
Ohms.
Ohm's
Ohm's
law.
law. Very good. Ohm's law, children. Okay, so next one. Next one, children. What is the next question? Is there like this third question? Please check all of you. A copper wire has diameter of 0.5 mm. Copper wire has diameter of 0.5 mm. Okay, and resistivity is 1.6 into 10 to the power of minus 8 ohm meter. What will be the length of wire if resistance is 12 ohms? What will be the length of the wire if resistance is 12 ohms? Okay, this is first question in this. Okay, children. So, children, when diameter is given 0.5 mm, see, children, how diameter I will change. You see, zero point 0.5 is diameter. Radius is 0.5 by 2, children. So, point if you remove 5 by 20, children, 5 by 20. If I remove this, okay. So, see here, children. 5 by 20 is 1 by 4 will come. This is in mm. How to convert mm to meters, children?
By
By
1000.
thousand.
5000.
5,000 children. So how will it will change children? R is equal to 1 by 4 into 10 to the power of 3. This goes up. R is equal to 10 to the power of minus 3 by 4. This is just radius only, children. This is just radius still. Okay. Second. Okay, children. So R is equal to rho L by pi R square. R is equal to rho L by pi R square. But we want the length, children. So length is equal to R pi R square by rho. Pi R square will go up, rho will come down, children. Okay, let's do here. I hope you all are concentrating, children. Please concentrate. Okay, children, how I'm doing it. See all of it. N is equal to R is on like children 12 ohms. Pi is 22 by 7. Okay, children, radius is 10 to the power of minus 3 by 4 whole square. Okay, and by rho is how much, children? Children, rho is 16 into 10 to the power of minus 9. Okay, children, actually 1.6 into 10 to the power of minus 8 no. So 16 by 10 into 10 to the power of minus 8. This 10 goes up, 16 into 10 to the power of minus 9, children. Now we have to simplify. N is equal to 12 into 22 into 10 to the power of minus 6 by 16 into 7 into 10 to 4 for the 16 into 10 to the power of minus 9, like this. So 2 8s are 2 11s are 2 8s are 2 6s are 2 4s are 2 3s are. So length is equal to 11 3s are 33 children into 10 to the power of minus 6. This minus 9 goes up plus 9 by 4 into 7 into 8 is there children. So we have to keep on doing children. Still, okay, 33 here 9 minus 6 is 1000. 4 into 7 into 8. 4 into 7 into 8. Now what happens when this is children here? So 4 25s are 100. Okay, children. So 33 into 25. 25 3s are 75. 25 3s are 75. 8 25 0 by 7 into 8 is there, children. So two fours are, ones are, twos are, fives are. Okay, children. So 4, 1, 2, 5 by 28 is coming, children. That many meters. You have to simplify, children. Kindly simplify this alone. Okay, that many meters is the answer, children. You have to do, children. There is no other alternative because whatever is.
Sir, you muted your device. Excuse me, sir, you muted your device, sir.
Sorry, children. Yeah. 1 second. Yeah. Fourth sum, children. Question is like this, children. How can three resistors, 2, 3, 6 ohms, are connected so that you get a total resistance of 1 ohm? You want 1 ohm total resistance. How do you get 2, 3, 6? How should we connect them so that you get 1 ohm? That is the question. So let's check in series 2 plus 3 plus 6. How much is it? 11 ohms. In series, it is not possible. Now let's check in parallel. 1 by RP is equal to 1 by 2 plus 1 by 3 plus 1 by 6. How much is it? 2, 3, 6 LCM, 6 children. 2 3s are, 3 2s are, 6 1s are. 1 by RP is equal to 6 by 6. This gone. So this up children. So resistance is 1 ohm in parallel connection. These three together will be 1 ohm in parallel connection, children. In parallel connection, this is positive. Next question, children. Next question, three resistors 5, 10, 15 are connected in series. 5, 10, 15. 5, 10, 15 are connected in series and a potential difference of, I'm sorry, 15 volts is applied, children. And a potential difference of 15 volts is applied. Okay, calculate the current flowing through the circuit. What is the total current in the circuit? How do you do it, children? Anyone have idea? Anyone wants to say idea how to do this?
Sir, V
Sir,
is equal to
total
IR,
resist.
sir. Total
Yes, sir.
resistance we should find in series. 5
Okay,
plus 10
very good.
plus 15.
Very
30,
good.
30 will get, sir.
Very good, very good. Total resistance we should find first. So RS is equal to R1 plus R2 plus R3, 5 plus 10 plus 15. RS is equal to 30 ohms. Now I is equal to V by R. I is equal to 15 by 30. Okay, 1 by 2. That is 0.5 amperes. Flows in all of them 0.5 only will flow. In all of them 0.5 amperes only will flow. Like that we have to do, children. Okay, so you should know when you are doing the sum what you are going to do. You should know, children. After putting the paper pen on the paper, you should not think. First only you should know what you have to do. Okay, children. Sixth question. Okay, children. Sixth question is like a voltmeter reads 24 volts. Voltmeter reads 24 volts across a resistor, and ammeter reads a current of 3 amperes. Ammeter reads currents of 3 amperes. Okay, calculate R. Calculate R. What will be the current through the resistor if voltage changes to 12 volts? If voltage becomes 12, current also becomes half. How much children? 3 by 2. According to Ohm's law, if potential is decreased, current also decreases. If potential is increased, current also increases. And we know V is equal to IR children. R is equal to V by IE. 24 by 3, that is 8 ohms is the answer. 8 ohms is the answer children. Okay. So that is sixth question children. Now, let's do some more questions children. One second children. One second. Give me time. Yeah. Seventh question children. Seventh question. Please check seventh question here. Three resistors are there, children. 1, 2, and 3 ohms are connected in series. 1, 2, and 3. 1 ohm, 2 ohm, 3 ohm are connected in series. Okay, children. To a battery of 12 volt. To a battery of 12 volt. Question is, determine the potential difference across R2. Across R2, potential difference is asking. Okay, children, do you remember children? Like this some side, is it? So first of all, we have to find total resistance. How much children? 1 plus 2
6,
plus
sir.
very good, 6 ohms. What is the total current children?
V by R. 112 by 6, 2 amperes.
2 amperes. Now, across V1, I wrote IR1. Across V2, I wrote IR2. Across V3, I wrote IR3. Do you remember children? And current is same in all of them. 2 amperes, 2 amperes, 2 amperes. Why? Because in series current is constant.
Constant.
So here 2 amperes children, 2, and here also 2 children. So 4 volts, this is 2, this is 3, 6 volt, this is 2, this is 1, 2 volt, 2 plus 4 plus 6, 12 volt. 12 volt is shared by 3 of them as 2 volt, 4 volt, 6 volt. I told you no children in derivation. Total potential will be shared by 3 of them in the series. Whereas current remains constant, all of them will have 2 amperes current only. In series, current is constant. In series, current is constant. You should have a sound knowledge about all these things. Next. Next question, children. Eighth question. Please check eighth question. Somewhat like this, children. This is the question, children. So here 3, 7, 10. 7, 10. And 5, 5. 1.5 volt. This is the question, children. Question. Children, find the total resistance in the circuit and total current in the circuit. Find total resistance in the circuit, children. Slowly you see, children. Children, 3 and 7, how are they connected? Anyone? 3 and 7?
Series.
Series, sir.
They are in series because they are connected to same wire.
Same.
Same
There is
wire.
no junction in the middle anywhere. There is no junction. So they are connected to same wire. So children, it is series, children. Okay. 1 second. Okay. So they both are in series. So now the figure will change like this. This is 10 ohm. This is 10 ohm. This is 5 ohm. This is 5. Now these both are how they are connected. Anyone?
Parallel.
Parallel.
Parallel. So 1 by R is equal to 1 by 10 plus 1 by 10. 2 by 10, that is 1 by 5. R is equal to 5 ohm. Now see children. This is 5 ohm, this is 5 ohm, this is 5 ohm. They are connected to a battery of 1.5 volt. Okay, now these three, how they are connected, children? These three are connected in series. Same wire, no, in the middle there is no junction. So three of them are in series. So RS is equal to 5 plus 5 plus 5. Total resistance is 15 ohms.
It is 10 no, sir. 5, 10, 5.
5, why 10? Why 10? 1 by 10, 1 by 10 is 5 you got now here. That 5 is substituted here.
Okay, sir. Okay.
So children, 5, 5, 5, 15 ohms I got. Now, total current I is equal to V by R. I is equal to V by R. Total current I is equal to V by R. How much is V children? 1.5. How much is R children? 15. So point if you remove 15 by 150, that is 1 by 10, that is 0.1 ampere. 0.1 ampere, like this. In the total current in the circuit is 0.1 ampere, children. You should know what you are doing, children. When the question is there, you should know what you are doing. Okay, children, one more question will do, children. So, ninth question. You have to practice all the sums, children. Then only you become sharp, confident in the subject. Ninth question. A wire of uniform cross section and length has a resistance of 4 ohms. Resistance is 4 ohms, L is there, A is there, cross section. Okay. This wire is cut into 4 parts. The wire is cut into 4 parts. Children, initially it is 4 ohms. Now it is cut into 4 parts. Means L by 4,
L by 4,
L by
L by
4,
4.
L by 4, L by 4. So 4 by 4, this also 4 by 4, 4 by 4, because resistance is directly proportional. If length is 1 by 4, resistance also 1 by 4. That is 1 ohm, 1 ohm, 1 ohm, 1 ohm. So each wire is now 1 ohm, children. Each wire is now 1 ohm. Now, what they did, children, after this, wire is cut into 4 parts. Each piece is stretched to length L. Thereafter, 4 wires are joined in parallel. Children, they are joined in parallel. These 4 are joined in parallel. Okay, children. So 1 ohm, 1 ohm, 1 ohm, 1 ohm. When all resistors are same, what is the formula, children? RB is equal to
R by N.
R by N.
This is 1, and how many are there? 4 are there. So 0.25 ohms is the effective resistance. Like this we didn't understand. It's like this also you can do. 1 by RP is equal to 1 by 1 plus 1 by 1 plus 1 by 1 plus 1 by 1. That is 4 by 1. Reverse both the cases, RP is equal to 1 by 4. 1 by 4 means 0.25 ohms. That's what I'm saying. 4 ohm is cut into 4 parts. So each part will be 1, 1, 1. Because when length is becoming 1/4, the resistance also becomes 1/4, children. Because resistance is directly proportional to length of the conductor. We discussed that. Okay. Next question. Children, are you able to hear my voice? Can anyone confirm?